Back again. So the derivative sine of u, it is cosine of u times u sub prime. Especially we're missing a lot of people today. They're going to need this. So if we have derivative sine 2x, again, that's u here. The 2x is u. The equation says it's going to be the cosine of u, that's the cosine of the 2x, that's u here, times the derivative of that, that's u sub prime. This is u now. The derivative sine of u is the cosine of u, this is the cosine, times u sub prime. This is u. The derivative sine of u is the cosine of u times u sub prime. Now let's do the cosine. What's the derivative of cosine u? Negative sine of u times what? Times u sub prime. Because you don't know what u is. U is a function of x. So what's the derivative? Cosine x minus 1. Again, this is u here. So the answer is going to be what? Negative sine of u, which is x minus 1, times the derivative of u, which is 1. So this is u, and this is u sub prime here. The derivative of cosine e to the x. Again, this is my u here. Negative sine e to the x times derivative e to the x, which is e to the x. So, but don't multiply this e to the x times this e to the x. This e to the x times the sine of e to the x. The whole thing. Bless you.
Thank you.
So this is times all of this. A better way to write it, that will be negative e to the x, that's that e to the x there, sine e to the x. This way you're not confused. Oh, that's e to the 2x. No. What do you think the tangent is going to be then? The derivative of tangent u. What's the derivative of tangent? Is it secant squared times the derivative u, which is u sub prime? What is the derivative of tangent x squared plus sine of x? Then make sure you memorize them. Derivative tangent is what? Again, this is my u here. So it's going to be secant squared x squared plus sine of x times the derivative what's on the inside, u sub prime, which is what? 2x plus cosine x. This is u here, and this is u sub prime. The derivative, let's try the cotangent since we added. That's negative cosecant squared u times u sub prime. The derivative of cotangent, let's do this. x squared plus 1 to the power 3. Let's combine what we just did. This is my u here. The derivative is going to be what? Negative cosecant squared x squared plus 1 to what power? 3. Am I done? Times the derivative what's inside the parentheses. How do you take the derivative of that? Yep, 3 times x squared plus 1 to what power? 2 times the derivative what's on the inside, which is what? 2x. So you got to remember all these rules there. We have 3 more rules. I'm going to write these. I think you get the idea. The derivative of secant u is what? Want to take a guess at it? Secant u, yep. Tangent u. Are we done?
U prime.
Times u sub prime. It's always a u prime. I wasn't about to do an example, but it doesn't take that long. Secant 5x. The answer to that is what? Secant 5x. Tangent 5x times the derivative 5x, which is 5. You can move the 5 to the front, make it look nice and neat. The derivative cosecant. That's negative cosecant u, cotangent u, u sub prime. You really want to memorize all of these. Just write them down every time you do the problem. So here we go. Derivative of cosecant 6x plus 1 is going to be negative cosecant 6x plus 1 cotangent 6x plus 1 times the derivative 6x plus 1, which is 6. And the last one in this section, there's a couple more new ones. The derivative of e to the u is going to be e to the u times u sub prime. So what is the derivative of e to the 5x? E to the 5x times what? Times the derivative 5x, which is 5. So that's 5 e to the 5x. And the new addition to that list, here we go. We didn't see these before, and that's the derivative of the natural log and the derivative of the log. Then I'll take a snapshot of a nice clean page, which is in our book there. If you have an older book, they all have it. When you have the derivative of the natural log of x, ln of x, it's always equal to 1 over x. But if that's not x, if that's a u, then the derivative of the natural log of u, just like the previous ones, is going to be what? 1 over u times u sub prime. Can we rewrite this? A lot of math books will write that u sub prime over u. Instead of 1 over u times u sub prime, they go, well, that's the same as u sub prime over u. So if we said to you, what's the derivative of the natural log of 2x? U is actually your 2x. That's u. So it's going to be the derivative of that, which is what? 2 divided by 2x. So what's the final answer? 1 over x. What's the derivative of the natural log of x squared plus 1? What's the derivative of x squared plus 1? 2x, very good. Over what? X squared plus 1. Can't simplify it. And the last one, what about if it's not the natural log, the log of any base? The derivative ddx of the log to any base. Does not be the common log. It is 1 over the ln of a times x. I always forget this one. And if that's not an x, if that's a u, what do you think it's going to be? Is it u prime over ln of a times u? Better believe it. And I'll do one more because the book seems to bring them here. We did e to the x, but what about if it's not e to the x, if it was a to the x? Any number to the x. That's the natural log of a times a to the x. And the derivative of a to the u, it's the natural log of a to the u times u prime. And that's all of the ones. Actually, the book doesn't even touch this one. Did they talk about this one? They just do this one. They don't cover this one. So our book brings this one up. They don't touch this one. They bring this. They don't touch this one. Here's what our book does for us, because it's a nice book. It does a summary of all of them on one page. And if you can see them all, so for now might be to your advantage. I'll take a snapshot of this too. But to have these on a piece of paper, if you have access to a book, copy that page and have them handy so you don't have to look back and forth all the time. It tells you the derivative of a constant is 0, x to the n, the quotient rule, the product rule. It gives you all the stuff. See that right there? They use u and v here. Product rule, quotient rule, the power rule, and all the trig functions, e to the x, a to the x, natural log, and log. And that's the end